If air resistance is negligible, the power required by a car to drive at a constant speed up a hill inclined at 30 degrees to the horizontal is P. What power is required by the car to drive at the same constant speed up a hill inclined at 60 degrees to the horizontal? There are many ways to attack this problem, but today I want to look at it from the perspective of power as the derivative of energy expenditure in relation to time. You will remember that this energy is made up of kinetic and potential energies. Now, in both cases, they tell us that the speed of the car is constant, which means that the kinetic energy is a constant value as well. Therefore, only potential energy is being invested into the system. Out of this multiplication, the mass and the value of the gravitational acceleration are constant. This means only the vertical position is changing over time. Therefore, the power is equal to mass times acceleration due to gravity times the vertical component of the velocity. P is equal to mgv sine of 30 degrees in the first case. Therefore, mgv is equal to 2p. This means mgv sine of 60 degrees is equal to 2p times the square root of 3 over 2, or square root of 3 times p. Since this is approximately 1.73p, the correct answer is option B.